In question 20, we're asked to take a look at the function f of x is equal to 3 times 5 to the x power, and it is being horizontally translated 3 units to the right. What is the equation that shows that actual application? So a couple of things that are going on here is we see that this is my starting point. This is what the ratio is, so it's multiplying by 5. But horizontally translated to the right is what I'm looking at. So there's a few different things that we're looking at. This is obviously 3 units. So when I'm looking at my choices in here, obviously the setups are the same. The only difference is that there is a 3 at the end of each of these equations, but in different spots. Now, horizontal translations versus vertical translations in a graph. The spot where a vertical translation, which is moving the graph up and down, are these big plus and minus 3s. So those right there, because they are at the end of the equation, they are full size, they are not part of the exponent. That is what makes this a translation, in this case up, and then this one would be down. Now what it comes down to is here between the exponents. So these two are horizontal translations because the exponent is being affected either left or right. So the plus 3, as we might have seen in one of the other videos, the equation is x minus c. So c would be the translated value. And so if I am plugging in 3 units to the right would be going this way, right? So we're thinking it's going to be in the positive direction. So this would be a positive 3 that I'm plugging in here. But if I'm plugging in a positive 3 into this equation, this is actually going to be x minus 3. So that would make D my choice. Now, again, does that make a lot of sense? Well, it does if you use the equation. This is going to actually make this go right. This is going to make this go left when this one goes right. And then we're going to check it on Desmos. So as you can see, here's the graph. This is what it looks like. And now when I plug in the equation, I'm going to go up here to the exponent, and you can actually play around with Desmos and see what this actually does to each of the graphs. I'm going to run out of time. So when I am putting the exponent in, I do want to put a set of parentheses around that when I'm doing this to double check that I'm correct, that a minus 3 does take that graph and it moves it 3 spots to the right because originally it was over here and now it's over here. So I hope that helps. Again, if I look at this, I'm just going to change the numbers around so you can see what a plus goes. You can see that's a plus 3. And that's just in the exponent right there. So